Hello, this is my Thomas Mobile Robot demo, created by me, Kevin Wynn, and my brother Richard Wynn. System architecture. So the project isn't fully completed yet, and I didn't integrate everything yet, but I'll be showcasing each of the core components, except for planning because we're still working on this. But for perception, this is where we'll be able to visualize the environment. Localization to know where the robot is. Path planning is to plan the path the robot will go on. Control for its movement, and a front end and back end to interact with the robot. So first we did discrete based localization, and I did this through a motion model set and sensor measurement. So on this image on the left, I use the sensor function to get the sensor reading. And in this example, I use an ultrasonic sensor, but I'll be replacing this later with a camera. Initially, we don't know where the robot is, so there's an 11% probability on each of the 9 tiles. But after the sequence of commands, we end up with a 76 probability of it being on this tile, which ends up being correct over here. Next, I implemented a low-level motion control. And this is because we noticed that the orientations weren't exactly 9 degrees on the turn, so there's gonna have error accumulating. So to fix this, I implemented a P controller on both going straight and turning. And I did it with these design requirements. And as you can tell, that the robot now is more precise and there's less drift. Next, we did perception to get the object detection and depth estimation. So this is a stereo camera where there's 2 camera, left camera and right camera. I first identified the landmark, so in this case it's a water bottle, and then got the centroid of each of them. From there, I used the centroid to get the disparity, which I can then calculate the depth estimation. And from this example, the depth was 0.804 feet. Lastly, this is the user interface where we'll be able to give it tasks and visualize where the robot is in its path planning. Thank you.